Section 2.4 Linear Functions. In this video, we're going to focus on basic concepts of linear functions, standard form, and slope. A linear function is defined by the equation f of x equals ax plus b. You've probably seen this before, but in the form y equals mx plus b. Domain and range of a linear function is always going to be negative infinity to infinity, because when we graph a line, we have arrows on the end, and those arrows are going to span forever to the left and the right, so covering the entire x-axis, and also forever up and down, spanning the entire y-axis. Example 1, we're going to graph f of x equals negative 2x plus 6 using intercepts. We're also going to give the domain and the range. So to graph using intercepts, it's going to be as simple as plugging in 0 for x and seeing what our y-intercept is, and plugging in 0 for y and seeing what our x-intercept is. So let's start with finding our x-intercept first. To do this, we're going to plug in 0 for our y value and solve. So my x-intercept is at the point 3, 0. For the y-intercept, we're going to plug in 0 for x. We get a y-intercept of 0, 6. And we can draw our line. Our domain and range are both going to be negative infinity to infinity because our arrows go forever in all directions. Example 2, we're going to graph f of x equals negative 3 and give the domain and range. This is going to be a constant function. So anytime I have f of x equals just a number, we need to know that that's a horizontal line. And it goes through the y-axis at whatever number. So here's my graph, just a horizontal line through negative 3. My domain is going to be negative infinity to infinity because my arrows are going forever to the left and the right. My range, however, is only going to be negative 3. So if we look at our y-axis, the only number that's used that's covered by our graph is negative 3. Same idea when we're graphing x equals negative 3. This time, however, it's a vertical line, and it's going to cut through the x-axis at negative 3. This time my domain is the number negative 3, and my range is negative infinity to infinity. So anytime we have a constant function, our domain and range isn't going to be all real numbers. One of them is going to be a single number. Example 4, graph 4x minus 5y equals 0 using intercepts. Give the domain and the range. So first let's find our x-intercept, plugging in 0 for y and solving. We got our x-intercept to be at 0, 0. Now, if you think of where that is on the graph, that's also going to end up being our y-intercept. But we'll do the work here to find out. So, since we need 2 points to graph a line, finding intercepts didn't really help us on this problem because I still only have 1 point for my line. So let's try to find another point. Let's just plug something in for either x or y and get out another point. So we're going to try plugging in x equals 5. When we do that and we solve, we get y equals 4. So another point that I can use is the point 5, 4. And then my domain and range, again, is going to be negative infinity to infinity for both domain and range. Next, we're looking at slope. the slope m of a line through 2 points is given by the following equation. If we're looking at a graph, we're going to think of it as rise over run. So going from one point to the next, how many units am I rising over how many units am I running? Remember, if you go down, instead of rising, it'd be falling, so it'd be a negative number. And if you run to the right, it's positive. Running to the left is negative. This part right here is just a fancy way of saying change in y over change in x. So how many did you go up? How many did you go over? If you're given points, this is what you're going to want to use over here, and hopefully that's really familiar. y2 minus y1 over x2 minus x1. Remember, your y's always go on top. So this is the most common mistake I see is people will write it with x is on top and y is on bottom, which would be wrong. Undefined slope is what we call the slope of a vertical line, and zero slope is the slope of a horizontal line. Here's a fun little way to remember your slopes. This is Mr. Slope Guy. His mouth shows us zero slope, so we have 2 zeros next to it. His nose shows us undefined slope, so there's a U right here. And then we have positive slope because it's going up, and his little eye is a plus sign. And we have negative slope because it's going down, and his eye is kind of winking at us. Example 5, we're going to find slopes using the slope formula. So I have 2 points here, so I'm going to be using the y2 minus y1 over x2 minus x1 formulas. So for this first one, I have -3 on top minus 8. So y2 minus y1. And then on bottom, I have 2 minus a -4. Make sure you have minus a negative there. When I simplify this, I get -11 over 6. I can't simplify -11 over 6 any further, so that's just my answer for slope. For B, I have -4 minus 7 on top and 2 minus 2 on the bottom. When I simplify, I get -11 over 0. I can't divide by 0, so this answer is undefined. Just a quick side note, if it had been flipped, so if I had gotten 0 over -11, I can divide that, and I would get out 0, so that would be 0 slope. Pause your video and try C on your own. You should get 0 slope because when we simplify, we have 0 in the numerator. 0 divided by -7 is just 0. In example 6, we're going to find the slope of the line 4x plus 3y equals 12. In order to do that, we're going to need to put it in y equals mx plus b form, or you can think of it as the function notation, which I showed you earlier, f of x equals ax plus b. So no matter what, we need to solve for y. The first thing I'm going to do when solving for y is move my x term over. I'm subtracting the 4x over. -4x and 12 are not like terms, so I cannot combine them, so I'm just going to put them side by side. I always put my x term first because that's what it looks like in both of these forms. And now to get y alone, I need to divide every term by 3. And now I can identify my slope, my m, as -4/3. Make sure you don't write that as -4/3 x. Example 7, we're going to graph the line that passes through the point -1, 5 and has a slope of -5/3. So try this on your own. Draw a graph on your paper, plot the point -1, 5, and then use rise over run to graph your line. For our slope, we could either put the negative in the numerator with the 5, so that would be falling 5 and running 3, or we could put it in the denominator with a 3. That would be going up 5, rising 5, and then going backwards to the left 3. So here's the graph that we should get. We have our point at -1, 5, and then if I go down 5, and then to the right 3. So I'm using this form of my slope. Then I get my next point and I can draw a line.